Like you said, I'm a lead technical architect at Zoro UK, and yes, I did come back just a month back from UK as well. I have a master's in AI as well. I've been in this company from basically scratch. I actually built their login and registration as well. So I've been from that time with the company. Zoro is actually a wholly owned subsidiary of a company in US actually called Granger. And they're also a multinational, huge conglomerate as well. We started about 8 years back. Right now we are doing about 1 million monthly active users on our e-commerce site. Yeah, I've been through quite a lot with this company. So, and very recently we tried out DSPy as well. So, and that is what I'm going to talk to you, all of you about. But before going into how it is in production, as in like in a company like that, I'll probably come to a few things about DSPy itself. If any of you have seen the DSPy website or the Versal app that they have built, there are 8 steps that are mentioned there, right? So these are the 8 steps that you need to do in order to think about how you go about building a DSPy app. So I'll just list them out and briefly talk about them, and I'll not go into a lot of depth there. I'll assume you guys know at least a bit about DSPy, but if you want to know more about it and things like that, you can come and talk to me later as well. So these are the 8 steps. So first is you want to define what task you're trying to solve, right? This task, we'll talk about a couple of tasks that I'll go in this particular talk itself. And then you'd decide the pipeline for your task. So this pipeline can be anything like my inputs are this, my outputs are this. From this input, I want to go to this output. And you have to then get a few examples ready for the tasks that you're currently trying to solve using an LLM. Then you define your data, what the set of defined examples, etc. are, the data that you're going to have there as well. And the most important part is going to be the metric. This is where everything about how you define the DSPy pipeline comes into picture and comes into play as well. The better your metric is going to be, the better your outcome or the evaluation that is going to be for your particular use case. Then you simply do a zero-shot evaluation, which means you don't do any kind of optimization at all. You run all the examples that you have collected through the DSPy pipeline without any without any optimization. You see what score it is getting based on the metric you have defined for your particular task. Then you go about compiling your optimizer for the task that you're trying to do. And finally, you keep iterating on this with better metrics or better examples, etc. and etc. So having briefly touched on this, I'll talk to you about 2 examples, one from my company and one outside. So the first task that I actually was building for myself is about translation. So I actually maintain a website called smriti.com. This is where I actually am collecting a lot of our Sanskrit scriptures and things like that. Pretty much all of the things maybe that you know might be there already. And one of the main problems for me was, where do I find translations for all these texts, right? And most of these texts could also be on archive.org or something. And if you even get them onto the site, there is no way to get all the translations there, especially for each verse and each word that is there, right? I actually found inspiration from Quran.com actually. So if you actually browse that website, you can hover on each word and you get translations for that. And there's nothing like that for us. So I thought, we should do something along these lines. So I went about, collecting all the data there, and I got stuck in the way because there's no way for me to do translation. And then I saw LLMs could actually help me with that. So that is one of the first things where I actually looked at doing translations using DSPy for this. So I just, the very first thing that you would try is put a prompt together, provide the Sanskrit words or something, and say, give me a translation for this, right? And most LLMs will do a pretty good job. But you want to actually hone in towards a better translation. or more towards how you want it to be. And that's one of the things I actually tried. Yeah, it is visible, thank you. So I did 3 different evaluations on this. The first one is the zero shot, which I talked about earlier, where you just give it a prompt and say, this is the words that I want you to translate, and it translates that, right? So that is the zero shot evaluation. And you have a set of examples which you want to actually move towards. You want the language model to move towards. And then you do the second level, which is what I did as what is called as a few shot. So you give it like 3-4 examples in the prompt itself. You say this is the actual verse, this is the translation for it. You give 2-3 examples, and then finally give a new verse for it and let it translate. And then you evaluate that. So that is called as few shot. And the third one is called MyPro, which is where DSPy actually optimizes both the number of examples that it's going to give to the LLM and also the prompt that it is going to give to the LLM. It is going to tune both of these together so that you get a better metric at the end of the day. So as you can see, the zero shot 51.7%. With few shot itself, it actually got a pretty big bump, which is 70.0. And finally with MyPro, it just got another small bump. I didn't try this with like a huge number of LLM evaluations, because the prompt itself goes to an LLM, gets fine-tuned again, and then comes back. So I just gave it like 10 iterations or so. So that's when it just gave me this 1.5% bump. So yeah, and based on that, I actually added some translations there, and also some explanations of each of these verses as well. So that is something you can see there. Just move on from here. So now about a LLM in production for an e-commerce use case. So in our company, we actually have about 3.5 million products that we sell through the e-commerce site. So it's actually a pretty decent assortment. I mean, more than any typical fashion brands, etc. Right? So one of our biggest problems is we actually have more than 300 plus suppliers, and they all supply similar kind of stuff, right? Like imagine Airbus or the TfL, which is the metro of London, etc. So these people, they want a specific exact screw, which means there is a specification for that screw. They want that screw which has a specific thread length, whatnot. So they will have like tens of hundreds of different attributes. And across different products as well. We in our site, we actually have more than 75,000 different attributes. So so if you see an example here, this is called function length for some particular set of products, and we have 2,500-ish products with that kind of thing. But this is a very typical problem that we have, because with 300 different suppliers, some of them may add 25.4 mm all in the same string. Some will have it as 25.4 and then mm in a different unit kind of thing. Some might have it in 2 inches, something like that. So it's all over the place. So there is no way for us to actually make sense of it or like normalize it. Or humanly, it is very, very hard to normalize this. So now when you actually see these in a search, right? Like I think I'm pretty sure most of you are familiar with Amazon, right? So when you look at it in search, you actually get them in an ordered manner. So think of a RAM or something, 8 GB, 16 GB, etc., etc. So if you have it in a very structured manner, it's very easy for a human to go and go through that, right? So now comes DSPy, or prompt optimization, as we are going to call it now. So with DSPy, the very first thing I figured out is that I don't actually have to write long prompts, first thing. I don't have to do any kind of prompt optimization like outside, like through hand, right? It automatically does the prompt optimization for me. Also, the other biggest advantage I saw was that it is LLM agnostic. So I can write a DSPy program. I actually did this in production as well. So we first started with Mistral 8P, And then for some use cases, that was not enough. So we just switched it over to OpenAI GPT-4o, and then it started working as well. Just one more compilation, and it works with GPT-4o as well. You can actually try various optimization strategies as well. I've shown you that through the Sanskrit one as well. And the other big advantage is that you can actually tune a smaller LLM like Mistral 8B with a more larger LLM, which is actually going to act as the trainer. So this trainer will give you examples, and then the examples or the feedback may come from the bigger LLM, and this only happens during the compilation phase. So in production for us, this is kind of how the architecture looks like. Our primary DB is Mongo. From there, we actually have a sorting job, which takes all the attributes from various different products together for a particular attribute, like function length that we saw earlier there. And then we actually go to an LLM sorter service. We request sorting for that. Now, at this point, we actually do two things, right? One is we first go to a smaller model like Mistral, and we first try to decide whether there is just an alphanumeric sort or not. So for things like shirts, right? We have screws and shirts as well, right? So it's a very huge assortment. So let's say for something like shirts, you have size, and size is like S, M, L, etc. Now you can't do an alphanumeric sort on this because it doesn't make sense. You need an actual logical sorting for this. So now for these cases, the Mistral actually is going to say, no, this is not going to be an alphanumeric sort. At that time, you go back to the sorting service, and then you go route it back to OpenAI. OpenAI is going to now make a decision that, this is how the sorting needs to be for this. It will sort the values and give it back. If it is an alphanumeric sort, then we can just do a Python-based, alphanumeric sort as well. So once we do this whole, sorting, we put it back into MongoDB and then serve it from there. One of the few learnings that I had from this, I got into DSPy pretty early on as well, just exploring like most of you guys on the LLM and other forums. The hardest part, obviously, which I mentioned earlier about DSPy, is actually figuring out what the metric needs to be. You can actually have very simplistic metrics to something like, do these two strings match, which is going to be a very simplistic one. To a bit more complex one, you need to find a numeric evaluator for an answer, for a text answer. You can do, we have done some things like cosine similarity and things around that. Then you can go even more advanced, where actually you can have another LLM or another DSPy program itself as one of your evaluators as well. And this evaluator then can determine or answer back questions for this particular metric. DSPy Discord channel is actually pretty resourceful. Even Omar, who is one of the guys who what's the right word? Invented yes. DSPy is there, and he answers a lot of the questions himself as well. The other important thing I figured out is that it's not really like a neural network. So with DSPy, I think most people make the mistake to think that it is neural network, because you're tuning what's the weights of your models, right? In neural networks, you're tuning what's the weight, weights of your models. But I think about it more like genetic algorithms. So you have your population, and then you have whatever you are optimizing for, because this is just optimization, right? Whatever you are optimizing for, and then you iterate over this until you find the best fit for your answers. So for example, the translations, I actually use cosine similarity as well. Works. I can go for more harder evaluation metrics as well, but for me, because it's a small one, it works. So yeah, so the Sanskrit translator is actually open source. You can actually check it out on my GitHub as well. I also started curating a list of all awesome DSPy resources. You can again check it out there.